Okay, so this is going to be section 1.3 of my PreAlgebra series, and here we're going to talk about adding and subtracting real numbers. So to do this, I'm just going to jump into just some examples, hopefully try to put it in a real-life situation. And again, this is just, sort of the basics you need to move forward into more PreAlgebra and algebra. So just the arithmetic, just making sure that we're ready for this. So, okay, so suppose you go to the bank and man, you've got $0 in there, and I've certainly been in that situation myself. Not a fun situation. Suppose though you've got a credit card that you can spend. Okay, so in part one, suppose you have $10. Okay, so I'm going to write that as a positive 10, and you gain maybe maybe you found $10 and maybe you got paid $12 for doing a chore or something. Well, now you've got 10 plus 12, or you've got $22. Okay, I think that's straightforward. Suppose you spend $10 on a credit card. So in this case, I'm going to represent the fact that we spent $10 because right now I owe $10. So I'm going to write that as negative 10. So I spend $10, and then I spend another $12 on that credit card. So I'm down $10, and I'm down another $12. So I've got negative $10 and another negative $12 that I've spent. Well, that would mean to me that I now owe $22, or I've got negative 22. So part three, suppose you earn $10. All right, so I've got $10 that I made, but you spend, and I spend $12. Well, how much money would you have or would you owe? Well, I've got 10, but I spent 12. That means I've got negative $2. I owe $2. And lastly, suppose you put $10 on a credit card and you earn another, I wrote that as positive 10. Let me be careful there. So suppose you put $10 on a credit card, but you earn $12. Well, in this case, now you would be $2 ahead. So you would have $2 in the bank. You wouldn't owe anyone anything at that point. So notice what we're doing here. The only real thing we're talking about is just look at the signs on the numbers that we're adding. So here they're both positive. Here I've got a negative and a negative. I've got a positive and a negative, and again a negative and a positive. So we've kind of got all four cases, and that's really what we're going to talk about in this section. So one way to visualize these, a very common technique to kind of think about these, is to use a number line. So that's what I'm going to do in this case. So suppose I want to add negative 3 and negative 2. So negative 3 plus negative 2. What would I do? Well, in this case, what I'm going to do, you can think about as a negative number as meaning go left on the number line, and you can think about a positive number meaning to go right on the number line. So my first number is negative 3. Well, that means I'm going to go left 3 units. So I've got 1, 2, 3. And I'm adding on another negative 2, so I'm going to go another 2 units to the left. Well, I'm sitting right here at this value, and that's going to give me the value of negative 5. So notice if the signs are both negative when we're adding them together, you can really just pretend that they're both positive. Positive 3 plus positive 2 is positive 5, but we have to include the negative. So this is something we'll talk about. I'll talk about that little notion a bunch in this section. So same thing, suppose we do negative 3 plus negative 6. Well, I would go 3 units to the left. So 1, 2, 3. And then another 6 to the left. So 1, 2, 3, 4, 5, 6. And that's going to leave me sitting at the value of negative 9. And again, if it was positive 3 and positive 6, you would get 9. And then remember just to include that negative. Okay, so last but not least, oh no, we've got 2 more. Sorry, I apologize about that. So positive 2, now we move right 2 units. But now we have to move to the left 5 units. So I'm backtracking. So there's 1 unit, 2 unit, 3, 4, 5 units. And that looks to me like we're sitting at the value of negative 3. And last but not least, negative 3. So 1, 2, 3 plus 7. 1, 2, 3. 4, 5, 6, 7. So there we would be sitting at the value of positive 4. Okay, so this is one way to visualize what we're doing when we're adding and subtracting these real numbers. So this is what I was trying to point out a second ago. So this is kind of a remark or observation. So if two numbers have the same sign we add their absolute values and give the sum the sign of the original numbers. So what that is saying to do, all that's saying to do is, okay, we've got this number -3, just pretend it's +3. I've got this number -8, just pretend it's +8. And again, we can do this because they have the same sign, right? They're both negative. So we can just pretend they're both positive. We still add them. We get 11. Well, okay, so you don't get 11 in this case because we have to keep this sign. So you get -11. So let's think about this one. What's +10 plus +14? Well, +10 plus +14 is +24, but they're both negative, so this is going to be negative as well. And last but not least, the absolute value of -28, we would just pretend it's +28. The -100 would be a +100. Well, if we add those together, we're going to get not 128 again, of course, but -128. So at this point, you know how to add numbers if they're both positive. Now you know how to add numbers if they're both negative. You just pretend they're positive and then just include that negative sign. Okay, so what do we do if the two numbers have opposite sign? So that's going to be the difference. Instead of having the same sign, they've got the opposite sign. Well, what we're going to do is we're going to subtract their absolute values and give the sum the sign of the number with a larger absolute value, okay? So what that means is, again, we're going to take the absolute value of both numbers. So +8, and then I'm going to have +12. And what we do is we take the difference of these two numbers. I always take the largest minus the smallest. So this gives 12 minus 8, which is going to be +4. But if I think about which number had the larger absolute value, well, 12 has the larger absolute value, and it says we give the sum the sign of that one. So in this case, it's going to be a -4, not a +4. So again, I see their opposite signs, a positive and a negative. I take the larger, I just pretend they're both positive. I take the bigger minus the smaller. I get 4, and again, the number with the bigger absolute value had a negative sign attached to it. Okay, so let's try this one. So the absolute value of -15/2 would be just a +15/2. So the absolute value of -15/2 is just +15/2. And then I would subtract away the absolute value of 5/2, which is just 5/2. That's going to give me 10/2 or 5. But again, -15/2 has the larger absolute value than 5/2. So this is going to be negative. -3 plus 5, well, this is going to be a 3. This is going to be a 5. Bigger minus smaller is going to be 2. And since 5 has the larger absolute value than -3 does, again, I'm just comparing these two numbers. 5 is bigger, so it stays positive. Okay, so a couple more properties here. We'll step through these, I think, pretty quickly. So we want to talk about the additive identity and the additive inverse property. And these are things that you'll use them, but you won't really be mentioning the fact that you're using, you won't mention them by name rarely. You'll just use them automatically. Nobody's going to ask you. Maybe except at the very beginning. So pick your favorite number. Okay, what number can you add to the original number and not change the value of that original number? Okay, so maybe your favorite number is 7. What can I add to that so that I get my same favorite number back? I want to get 7 again. Well, the only thing I can add to 7 and not change it would be 0. Maybe your favorite number is -23/4. Well, what would I add to that to get, again, my favorite number of -23/4? Well, again, I would just simply have to add 0. So this number 0 is known as the additive identity. It's the only number that you can add to another number and not change it. Okay. You can also think about the a multiplicative identity. What can you multiply any number by and not change it? And a hint, it's not 0. But just like for the operation of addition, this is going to be our additive identity. Eventually, you'll talk about one for multiplication as well. Okay. So another question here. So pick your favorite number, and we want to know what sum can you add to this number so that the sum is equal to 0. So now I'm starting with a number. and I want to add some number to that and get 0. Same thing, negative 10, I want to add some number to that and get 0. 2 over 17, I want to add some number to that and get 0. Well, for 3, I guess I'd have to add negative 3, right? Because 3 plus negative 3, they would just cancel each other out and give me 0. You know, I move to the right of the number line 3 times, then I move back to the left 3 times. That's still going to put me at 0. Well, negative 10 plus positive 10 would give me 0. And 2 over 17, I would have to add negative 2 over 17. So when you find the additive inverse of a number, there's not one, for each number there is a different specific number, okay? So there was only one additive identity. And this works for any number that you start with, right? So maybe this is worth pointing out. When we do what's known as the additive inverse, each number has its own unique, different additive inverse. So I'll say for the real number a, let's call it something generic. Negative a is the additive inverse. Okay, and again, 0 is always the additive identity. Okay, so let's talk about subtracting real numbers. And we've already really done some of these already. And what we're really going to do, we're going to allude to this. What we can do is we can write, this is sort of the basic idea, you can write a minus b. We can write this as a plus negative b. And then, you know, use all these techniques that we were doing earlier on when we were adding, you know, when we were adding all these different numbers together. So this is the idea. And this is useful to know, too. So when you see a positive and a negative, we've got this negative b. You can also just immediately rewrite it as a minus b if that's how you would rather think about it. So interchangeable notation. So 15 minus 6, well, 15 minus 6, if I wanted to, I could write this as 15 plus negative 6. But 15 minus 6, that seems like, you know, sort of basic arithmetic. We can just subtract. If I've got $15 and I take away 6 of those, I've now got 9 left. So negative 3 minus 8, this is one of those conditions again. So we could rewrite this as, sorry there, let me get my color. So we could write this as, again, since they both have the same sign, so I could write this as negative 3 plus negative 8. And since they have the same sign, I could take the absolute value. So that would be 3 plus 8, that's 11, using this little trick we were talking about earlier. So I would get not positive 11, but negative 11, because both numbers are negative. Okay, 6 minus 15. Okay, that's going to be 6 plus negative 15. And again, we said we take the absolute value of each of those numbers. So the absolute value of 6 is positive 6. The absolute value of negative 15 is positive 15. And remember, the absolute value of a number, if it's 0 or positive, it stays the same. If it's a negative number, you just get the positive version of that. And if we subtract those, 15 minus 6, again, that's going to be negative 9. And we said you keep the number with a larger absolute value. 15 has the larger absolute value compared to 6, so we use that negative. Right? And intuitively to me, when I look at this, I think, well, you know, I'm much more in debt than I'm getting back. So I know I intuitively still have to be, you know, negative. So maybe that's one way you can think about it. Same idea on this one. Let's take their absolute value. Let's see, the absolute value of this is going to be positive 3.7. And then I'm going to subtract away the smaller number, which is 2.4. And again, if you wanted to, you could write this as 3.7 plus negative 2.4. Well, I would just subtract. This is a bigger number minus a smaller number. And notice I'm subtracting a positive minus a positive. So this is just going to be 1.3. Let's see our next one. Using this property that we had that I showed a second ago, so we can go from this direction to this direction. So if we have a positive and a negative, that's going to be a negative. Another useful property to know is that a minus negative b, that's going to be the same thing as a plus b. So this is another useful property to use. So I always see, you know, if I see two negatives, I always just think I'm going to make this a positive. That's 8 plus 10, and that's going to give me 18. So the same thing on this one. We can use that example one more time. Negative 4 over 7, I've got two negatives. That's a positive, which is going to be 9 over 7. And again, I take the absolute value. 9 over 7 has a larger absolute value than negative 4 over 7. The absolute value of that is 4 over 7. I'll take the larger minus the smaller. Again, we just do the arithmetic in the numerator with fractions. So 9 minus 4 is 5 over 7. And let's see, our 9 over 7 had the larger absolute value, so this is going to stay positive. We just don't write it. So let's do a couple more examples. Negative 2.6 plus 4.9. We could write this as 4.9 minus 2.6. So that's simply going to give us 2.3. So that's how I would think about that one in my head. Negative 8 minus 4. So I'm going to go through these all a little quicker. Those have this, if they're both negative, we said you just add those values together and keep the sign. So negative 8 minus 4, I'm thinking what's 8 plus 4 since they're both negative, and then just including that negative at the end. 12 minus 5, well, that's kind of more familiar, a larger number minus a smaller positive number. So that's going to be 7. Okay, our last one, okay, we've got two negative numbers, so I'm going to add them. So I'm going to make this 5 over 9 plus 7 over 18. Well, I could get common denominators of my first fraction, right? We need the same number on in the denominator by multiplying only the first fraction by 2 over 2. Let's see, so that's going to give me 10 over 18 plus, we said 7 over 18. That's going to be 17 over 18, and that doesn't reduce. And again, since they're both negative, the final answer is going to be negative 17 over 18. Okay, so 12 plus, negative 12, that's its additive inverse, so I could just make this equal to 0. And here's a couple with a few more numbers. So here what I'm going to do, if you peeked over at me doing this on a test, this is how I would probably do it. I mean, you could add these two together and then add the negative 3.6. I'm going to add the two negative numbers together. Again, since they both have the same sign, so I'm going to leave my 2.4. That's just going to drop down. I'm thinking about doing 5.1 plus 3.6. Again, because they both have the same sign, they're both negative. So that's going to be 8.7. 8.7. But it's going to be negative. So I've got 2.4 plus negative 8.7. Well, again, these are opposite signs, so I'm going to take the larger number, the absolute value of the larger number. Well, the absolute value of negative 8.7 is 8.7. I'll subtract away the absolute value of 2.4, which is just 2.4. That's going to give me 6.3. But again, the number that gave me the larger absolute value came from the negative number, so this is going to be negative 6.3. And again, intuitively, right? If you're in debt almost 8.7, you can think about that as being you're in debt $8.70. You get $2.40. Well, you're still going to be down a bit, so still negative. Same thing in this one. Now I've got four numbers. So I'm going to add these pairwise. I'm going to do 3 plus 9 and negative 5 plus negative 2. So 3 plus 9 is going to be 12. Again, these are both negative here, my negative 5 and my negative 2. So I'm going to add those together and get 7. But since they're both negative, I've got to add negative 7. So 12 plus negative 7, that's the same thing as 12 minus 7. A positive and a negative give a negative. And that's simply going to leave me with 5. Let's see. So I was going to save this remark, but I went ahead and pointed that one out earlier, and we used it a little bit. And let's see. So I think I even utilized it. I was going to show these in a different way. So I did number 1. Let's look at the very last one here. So there's a couple different ways that you can handle this last one. And what I'm going to do is move terms around. So I can kind of pick these up in like one little little chunks. So this is positive 8, negative 9, positive 4, negative 11. You can interchange these in between any any number and sign that you want to, is what I'm trying to say. So what I'm going to do is move things around. I'm going to put the 8 and the positive 4 together. And then I'm going to put the negative 9 and the negative 11 together. So it's kind of like, this one's moving in between here, and this guy is just kind of sliding over. Okay, so, and now I can think about this as being 8 plus 4. plus negative 9 plus negative 11. Well, 8 plus 4, that's going to be 12. I've got two negative numbers, so I can pretend they're both positive. So 9 plus 11 would be 20, but they're not. They're negative. So I've got 12 plus negative 20. Again, I could take their absolute value. The absolute value of negative 20 is positive 20. The absolute value of 12 is 12. Larger minus smaller is how I always did it. That's 8. Well, the absolute value of 20 is bigger than the absolute value of 12. So it's going to be not positive 8, but negative 8. So, okay, a bunch of different examples there of just adding and subtracting numbers. Again, this may be something that's very familiar, or maybe it's something you haven't seen a lot of, but you definitely want to be familiar with it as you move forward.